Hello everybody, and thank you for attending my talk. I'm software engineering and data scientist at Alireza, and today I'm going to talk about some domestic challenges we face when performing sentiment analysis in special and natural language processing in general for the Swiss market. If you live in the French-speaking part of Switzerland, you will never notice the majority language of the country until you want to see some user reviews of the product you want to buy. And then, no matter how many languages a website supports, people write reviews in their own language, so aesthetically 70% of the user reviews will be in German. And if your German level is like me, you will have difficulty on understanding whether the product is good or not. So, how should a website be designed or a service in general in order to really support the multilingual nature of Switzerland or any multilingual country for that matter? The problem in natural language processing for multiple languages is that there are a lot of pre-processing and sometimes post-processing tasks which are language dependent. There is lemmatization, there is stemming, and there is a stop word removal, which are all dependent on the language you assume for the text you are analyzing. For example, in a stop word removal, you may have po in English, which is not a stop word obviously, or po in French, which is a stop word. Or if you want to remove the prefix of the French or German language, then the ambiguity will be increased even more, such as between the English there and the French there. And also we have recently seen more than validity used for natural language processing, and they also have their issues with multilingual support. Of course, there are solutions for them, but that's not. One thing you can do, the obvious choice, is to first do a language detection, and based on the language you have detected, perform every language-specific task you want and return the result in the easy way. The problem is that it's an additional pre-processing step into your pipeline, and not only it is time-consuming, but also it is not precise. These are the results of running an ordinary language detector library of Chitika on some product reviews gathered from Swiss retail websites. And you can see totally kind of outlier languages detected for text, which sometimes is quite obviously in English or French or German. And the reason for that is that we have the text, which is usually short, when we are talking about product reviews, and usually written in colloquial language, and even worse, usually written with sarcasm in terms of sentiment analysis, which is not easy to recognize and not easy to analyze for most of the natural language processing stuff. So again, here we are seeing some examples, some real examples from retail websites in Switzerland. So what we thought about was to design something in a language agnostic way, which will be useful not only in sentiment analysis, but also in a lot of other scenarios, such as request routing for customer care websites, in chatbots, in dialogue management services, and everywhere you are interacting with the user, where you cannot necessarily assume that they speak a certain language. And if you are dealing, for example, with English-speaking users in Switzerland, then they will have a lot of issues to face when contacting customer care services or different centers or contact centers in Switzerland. So, what if it is possible to do some language agnostic text processing where there is no prior assumption on the language of the text that you are going to analyze. And the only thing you have is some data, hopefully an appropriate amount of data, where you can learn your model from. And as a result of no prior assumption on the language, then there is very little pre-processing you can apply to your text data. And we wanted to see how does it work, and does it work any better than just pouring a lot of single language data and just expecting a 70% accuracy, for example, for Quarteroni. So we crawled a lot of, not about the ones that I found, Swiss retailer websites for their product reviews, and based on some analysis, usually 50 to 55% of the reviews were in German or Swiss German actually. 20 to 25% were in French, and the rest were were in mostly English, a little bit Italian and other languages. And the IKEA website is a very interesting case for that matter, because the website is more or less the same, with more or less the same products in a lot of countries. So if you get the product reviews in the IKEA Switzerland website and in the IKEA Austria website, then you will have a good base for comparison. The IKEA German website actually doesn't have product reviews, I don't know why. And you can also use the IKEA US for English and IKEA France for French language. For the pre-processing, the very limited steps we had were tokenization, obviously the very simple tokenization based on spaces. Then we remove diacritics. It may add ambiguity, but in our experiments it led to better results, probably because a lot of people, for example, when they want to type French, they may not have access to a French keyboard, so they just ignore diacritics. And removing punctuation, which is the ordinary step, and then there is the step of removing a stop word, which if you want to do it for multiple languages, then one word may be a stop word in one language and not in another. But again, in our experiments, removing the union of all the stop words led to better results than not removing any of them. And then, in the classification algorithm, for which we use gradient boosting, and it led to impressive results for our case, probably because of its nature, where there is less danger of overfitting and better generalization, and probably because of its adaptability to different scales in the features, and its computational efficiency was quite good for our case. We also tested deep neural networks for classification. They didn't work well, mainly because of the amount of data that we had access, which was quite limited. So the task was to separate negative reviews from positive reviews in the Swiss market reviews that we had gathered. Here we see the ROC curve for the classification task using the gradient boosting and the pre-processing step. The area under curve is about 0.95, and we can see here that it is quite promising. And as a comparison, here we are using Swiss product reviews for training. If we use German product reviews, but in a more more volume, in a larger volume than the Swiss product reviews, we are seeing that the results are actually worse. So it matters to use the data gathered from the Swiss market and not just more data gathered from the German market. And if we combine the German market, the German product reviews with French product reviews and use them instead of only Swiss product reviews, we can see that we see very little improvement, and we still have a superiority by using the Swiss product reviews. And finally, we see here the effect of the size of the training set. The maximum we had was about 20,000 product reviews, and we can see that there is a clear decrease in the error, which is, our measure was 1 minus the area under curve for the binary classification, and there is room for improvement. So, if there is a way possibly to gather more data and more product reviews, there is room for more improvement. Finally, what we can think about this experiment that we have done is that there is probably some way to have a better design of, say, text-based products for the Swiss market by just letting the users not bother themselves with the language they want to speak about. And we can work on designing, say, a language model for a hypothetic, kind of superficial Swiss language, which combines characteristics of Swiss German and Swiss French, and probably Swiss Italian, that was very scarce in our data set, and do a much more automated task when dealing with services for the Swiss people, and essentially consider the Swiss French people in calculations usually, because most of the products that we are working on, and I have seen, are usually designed for the Swiss German speaker in mind, which is maybe unavoidable for now, but our experiments show that maybe we can do better. Maybe we can do better and remove the language barrier from a multilingual country like Switzerland. The multilingualism in Switzerland bears with itself some costs, such as the deal activity costs that we all pay, but there are a lot of opportunities that we can use and work on products that adapt to this market. Thank you.
So I understand you had the data, yeah? But with every review, did you also have the stars, which told you how good it was? So that was the source of sentiment information?
Yes.
The only source? You didn't add any other sources? Okay.
Yes, usually there are kind of 5-star reviews. We remove the 3-star because that's ambiguous, and we consider 4 and 5 as positive and 1 and 2 as negative, and design the final classification.
Just one of the things you said you did was removing punctuation. Do you consider an exclamation mark for punctuation?
Consider what?
Exclamation marks. Usually,
yes,
strings of exclamation and question marks signify sentiment intensity. So then at least it would give you some hint, whereas some review that's borderline, like 3 stars, maybe up or down.
Yes, that's true for sentiment analysis, but we had kind of a broader view in mind to do more general text classification tasks for other problems as well. I cannot talk about them unfortunately, but sentiment analysis was just kind of a showcase for us. We had other problems for which the punctuation on that indicated. So that's why we removed them, and that usually led to better results because of the tokenization, because our tokenization is very naive. So it worked better if you remove all the punctuation.
Since I've worked myself with some of these things quite recently, I can tell you, in some cases I've actually found it interesting to keep punctuation because it splits the review up into bits. Usually when you review a product, you can say it's good for something and bad for something else. Right? Especially if you don't give a 1-star review or a 5-star review, if it's anything in between, you have things to say on both sides. both ends. So having something like commas or full stops to split up little sentences in the review or blocks, contiguous blocks, help distinguish kind of more lower level sentiment. And then if you aggregate those together, you might get a better overall sentiment of the sort of review. And then if you're probably doing reviews, you also care for customers. You also care, is this sentiment applied to this product feature or not? So it will also help you if you do some engram, some keyword recognition at that level. So, okay, this part of sentence, I have positive sentiment clearly, and I can see it mentions, I don't know, battery life. So then you can immediately assign the verdict locally, and then you give more information.
That's very interesting. Thank you. This project is ongoing, obviously, continue work on that, but the mindset we had when doing everything was that it should be as much language agnostic or language independent as possible. We shouldn't assume, for example, for engram detection, usually you assume something about the specific language you have in mind, and if it is too much engrams, then the feature space becomes too big. So, and if we already have multiple languages, so our feature space is quite large. So there are some challenges like that, but thank you very much.
Yeah, for engram, punctuation.
We have time for one more question.
You are now completely agnostic with the language, but in certain cases, you know, for example, you have, let's say, German and English. You know it's one of those two languages, you don't know which one. Do you think in those cases, would it make sense to do a bit more pre-processing steps, maybe look a little bit more at the stop words which exactly you have to remove, or do you think the time would be better spent somewhere else?
Yes, that would probably work, but the problem we had was that for some of the kind of the pre-processing tasks that we had, it was quite difficult to combine them together. The stop word removal was one example that it's not easy to just take the union of all the stop words and for some other tasks as well. So we had this problem, of course, but as I showed in the experiment, simply combining, for example, a German product review dataset and an English product review dataset is not the same as having there is no German-English country, but for example, the French-English Canada is quite different to have a kind of original Canadian dataset than combining an American and the French dataset. So we prefer to work with the kind of realistic datasets rather than combining the different language models. And we hopefully want to create a unique language model, a unique combined language model, because we believe, based on our experiments, that will work better.
Thank you very much. Should be time for changing rules, unless there is maybe a short question.
Because if you don't recognize the language, how do you know which language you should respond?
For now, of course, that's the issue. That's probably the next part of our project. For now, our goal is to kind of detect the sentiment of the text. Then to see to what language to respond, probably it can be location-based maybe, or some other convention. But that's not what we are thinking.